most welcome to this lesson. I am teacher Katimbo Richard, teaching mathematics. Today I've come with one of the most important topics in mathematics, which when understood, we have gone a long way in as far as understanding mathematics in general is concerned. The topic today is algebra. Algebra helps us solve most of the problems in mathematics. Therefore, I ask you to follow strictly as I do explain. Algebra in general has got four forms of collection of like terms, simplifying, solving, and substitution. I say it has got four forms, that is of collection of like terms, simplifying, solving, and substitution. So let the viewer follow so that that viewer shares those four forms. We shall start with one form of simplifying, like number one suggests. Simplify the following. Part A says m plus m plus m. M plus m plus m. In addition, like here, it is accumulation of things, collection of things together. So here you are going to just count the m's around, that is 1, 2, 3. That's why the solution says m plus m plus m is equal to 3m. So we have simplified. Then part B says m times m times m, as opposed to part A that was for addition. This is for multiplication. Unlike addition, in multiplication, so long as the number ones multiplying is the same, here we count the indices, the ones sometimes people call powers, but they're actually indices or exponents. So m times m, you count in terms of indices. That is in m index 1, m index 2, m index 3. So m times m equals m index 3. Remember, in part A it was 3m, that was addition. In part B, being multiplication, these are indices of m. M times m, that's m index 2, times m, that is index 3 of m. So answer is m index 3. Then we can look at part C. Part C says 3 times m. In part B, having learned how to multiply the same and digit, we then add on a figure or a digit, like 3 times m, where you multiply m by m and get m squared. Thus, you say 3 times m, that is 3 times m squared, which is equal to 3m squared. So be careful about every example, for every example brings its own way. Then go to example or part D of number 1, which says simplify y squared times y cubed. Y squared times y cubed. In doing that, you are going to expand y squared, which means y times y, and y cubed, which means y times y times y. So this one shows you the number of times y must be multiplied, that is slice, that is y times y times y, then y squared, that's y times y only. So therefore, the first way of doing it is through expansion, that is y times y in the place of y squared, then this times, when you go y cubed, which means y times y times y. Then you count the indices of y, the first index of y, the second index of y, the third index of y, the fourth index of y, the fifth index of y. That's why the answer is y index 5, or the fifth index of y. And this is the answer to that question if one opted for that. This is easier and not more technical than the next way. So alternatively, one that is technical enough will use this one. So this is what's called the index rule. The index rule says, given the same base in multiplication, one adds the indices. Given the same base in multiplication, one adds the indices. Now, I've used that technical way, and the words I've used are very technical. One must know that a number or a letter with an index is called a base. So when I say y index 2, y is the base, then 2 is the index. Y is the base, then 2 is the index. So now I've got the same base y here, y and y. So given the same base in multiplication, one adds the indices. Why are we adding? Because multiplication as an operation means repeated addition. So that's why we use addition to work out multiplication. So the index rule states that given the same base in multiplication, one adds the indices. That's why we maintain the base y, and now these indices, that is 2 and 3, are added to just simplify it technically. So you say y index 2 plus 3, which is equal to y index 5. This is very technical. If you are not sure of this one or this style, please use the other style of just expansion. But it will add, or you'll be assumed to be knowledgeable in mathematics if you use this way of simplifying that number, which index rule states that given the same base multiplication, one adds the indices. That's why you say y index 2 plus 3, which 2 plus 3 is a 5. Thus the answer is y index 5. That way, you'll be successful in simplifying that number. Then part E says, simplify a index 5 divided by a index 2. A index 5 divided by a index 2. Like we did in the number before, that's part B. Here we are having two ways or so. That is the one of expansion and the one of using index rule of division. So we are starting with expansion. Remember, a index 5 divided by a index 2 is the same as a index 5 out of a index 2. That's why we make a index 5 expanded as the numerator and index 2 as a denominator. So we start with a index 5, ensure write 5 times those a's. A's, all those a's must be written 5 times in expansion. That is a times a times a times a times a. A times a times a times a times a. Ensure they are 5. Count them and see. 1, 2, 3, 4, 5. Then divide by whatever is say out of, you actually dividing. Divided by a squared, which is expanded, twice, that is A times A. 1, 2. So the A's are supposed to be 2. And then the out of course for division. And whenever doing the cancellation in mathematics, we actually dividing. So we divide by A. A divided by A is once. A divided by A is once. One pair is gone. We go to another pair. A divided by A is once. And A divided by A is once. So remain A times A times A. And I told you one must care about the indices if it is multiplication. That is A index 1, A index 2, A index 3. So the answer is A index 3, or simply A cubed. That is if somebody or one used the expansion style. Then the technical part is when somebody uses the index rule of division. Remember that of multiplication was saying, given the same base in multiplication, one adds the indices. Now this is division. So it states that given the same base in division, one subtracts the indices. Given the same base, the base is A and is common. In division, one subtracts the indices. So you maintain A and say A index 5 minus 2, and then simplify it as A index 3. So one that's technical can actually use that style. So n of the 2 gives you maximum marks. So you are free to choose between the 2, or have the 2 in the head and then write according to your wish. In so doing, you will be able to answer all those. Before we go to part F of simplifying different algebraic equations. So part F tells you to simplify 2y, 3p plus 3p plus 4y minus 6p. Simplify 2y plus 3p plus 4y minus 6p. Here you are supposed to first collect the y's together and the p's together. That is what's called collection of like terms in algebra. So we are going to collect the y's together as well as the p's together before we do actually simplify. And remember, when one is collecting like terms, one maintains the positivity or negativity, or one maintains the plus or the minus that is leading that particular number. This is a plus 3p, it must remain plus 3p as you are collecting like terms. This is plus 4y, it must remain so, as well as the minus 6p. So we say 2y plus 4y, I say to maintain that plus, and then plus 3p, and then finally minus 6p. And now, being that the y's are together and the p's, then we can do the needful simplifying. So 2y plus 4y, you get 6y. Then 3p minus 6p. In fact, being that 6 is greater than 3, then think about the negative outcome. 3 minus 6 is a negative 3. So 3p minus 6p is a minus 3p. So the answer is 6y minus 3p. In that regard, we have simplified. And remember, these are y's, these are p's, then they cannot simplify further. So they are unlike terms. So the final answer is 6y minus 3p. And then that's all to that part F. Then go to part B that tells you to simplify, this time when brackets are involved. Simplify 4 into p plus 2 plus 2 into p minus 2. Here, the first thing is one opening the brackets. Open the brackets. Then, how does one open the brackets? One opens the brackets by multiplying the content of the brackets by whatever is outside. In this case, 4 is outside the brackets. So multiply 4 by whatever is inside the brackets, and multiply 2 by whatever is inside the brackets, and then the brackets will have gone. And then again, when one is multiplying or opening the brackets, one must consider what is opening the brackets. Which kind of integer is opening the brackets. So like 4 is a positive integer as well as the 2. When a positive is opening the brackets, all the signs inside the brackets are maintained. I repeat, when a positive is opening the brackets, all the signs inside the brackets are maintained. So this plus will make a plus as we open, so will the minus remain. So the minus will remain a minus. So a positive outside the brackets maintains every sign inside the brackets. Whereas if the opener is a negative, all the signs inside the brackets change. That one must be taken into account before the opening of the brackets. Now that we have got positive openers, that is 4 and 2, the signs inside, that's the plus and the minus, will be maintained. For a positive opener, outside the brackets does maintain every sign inside the brackets. Now we are going to open. 4 times p is 4p. 4 times 2 is 8, which is still a positive 8. Then go 2 times p is 2p. Then 2 times negative 2 is a negative 4. Thereby getting 4p plus 8 plus 2p minus 4. The signs remain constant. Before we go to the collection of like terms, collect the p's together and those without p's together. So the next step is 4p plus 2p plus 8 minus 4. And then you add them. So 4p plus 2p is 6p and 8 minus 4 is the 4. Then the simplified algebraic equation or expression actually is 6p plus 4. 6p plus 4. In that way, never should you add these two because these are p's and these are not. So the answer is 6p plus 4. Don't add 4 to 6 please, because these are not p's. Had they been p's, you would say 10p, but now the 4 are not p. So the answer is 6p plus 4, and that's all. You get the maximum marks in doing the simplifying as told or asked by the examiner. Then you go to part H of number 1, which still tells us to simplify 3 into y plus 4 minus 2 into y minus 4. Unlike part D where this one is a plus, this is a minus in part H. And therefore, you need to know the difference between the setting D and that of H in a way that here the opener is a positive which maintains a plus sign of addition here, whereas here the opener is a negative, like I said, a negative opener changes every sign inside the brackets. Please remember that. And now we are going to open the brackets by multiplying and remembering that the positive opener maintains the sign inside the brackets and the negative does change every sign inside the brackets. So we multiply. 3 times y is 3y, 3 times 4 is a positive 12. So that by getting 3y plus 12, that is without brackets. Now, then negative 2 times y is negative 2y. So y being a positive, it has changed to now a negative. So negative 2 times y is negative 2y. And then negative 2 times negative 4 is a positive 8. So, like we said, this minus must be changed to a plus when you are putting the brackets using a negative. Remember to change the sign because of the negative opener. Repeat, 3 times y is 3y. 3 times positive 4 is positive 12. Negative 2 times y is negative 2y. and negative 2 times negative 4, you get positive 8. So the bracket free statement is 3y plus 12 minus 2y plus 8. And then one gathers the y's together and those without y's. So we say 3y minus 2y as it is here, plus 12 plus 8 as it is here. Before you finally simplify, that 3y minus 2y remain with a single y, which single is written as y. Never write 1y, please never write 1y. Algebra don't say 1y, 1x. So just write y, then 12 plus 8 is 20. Simplifying the whole issue as y plus 20. And that is considered a simplified kind of algebraic expression. Then go to number 1, part I, which tells us to simplify. This time there is involvement of fractions. That's a quarter into 12n plus 8m plus a half into 10n minus 6m. Repeat, simplify a quarter into 12n plus 8m plus a half into 10n minus 6m. This time round, there is involvement of fractions like I mentioned before. Unlike the other numbers who have been opening the brackets for, this one we multiply directly. We write a remultiplication here. So we are going to open the first brackets using a quarter and the next or the second brackets using a half. So again, remember the positivity and the negativity of the opener. So a quarter is a positive one and so is a half. Therefore, we shall maintain our signs inside the brackets. So we start opening the brackets. We say a quarter times 12n, that is the one put in brackets like that, and say plus is maintained, still a quarter times 8m, put it in brackets, and say plus a half times 10n, put in brackets, then minus a half times 6m, put in brackets, and now start dividing. 4 by 4 once, 12 by 4 you get 3, so I've got 3n here. Then 4 divided by 4, 1. 8 divided by 4, you get 2, that's 2m. Then 2 divided by 2 is 1. And then 10 divided by 2, you get 5. That's 5n. Then 2 divided by 2, you get 1. 6 divided by 2, you get 3. Remember m, of course 3m. And now we are going to multiply. 1 times 3n, you get 3n here. 1 times 2m, you get 2m. And then plus 1 times 5n, you get 5n, then minus 1 times 3m, you get 3m, thereby getting a new expression as 6n plus 2m plus 5n minus 3m. You are going to gather the n's together and m's, maintaining their positivity and negativity. So I've got 3n plus 5n plus 2m minus 3m. So this is the statement you have when one collects like terms. So 3n plus 5n, one gets 8n, and now 2m minus 3m, we get a negative outcome. 2 minus 3, we get a negative 1. And remember I said don't write 1 against the unknown. So you say 8n minus m, just like that. You get the answer simplified. So that's how one opens the brackets using fractions. One simplifies that, one collects like terms, and thereafter getting a simplified expression of mathematics like that. Then go to number 1, part J, which tells us to still simplify 2n squared times 3n index 4. 2n squared times 3n index 4. Here 1, first look at the digits themselves, that's 2 and 3 multiplied, and then n squared and n index 4 multiplied. Next step, we say 2 times 3, like we are here, then times these other n's, that's n squared times n index 4. Then you will get 2 times 3 and 6, then expand these ones, n squared as n times n, and this times here, then n times n times n times n, that's 4 times, thereby getting n times n times n times n times n times n. And now remember the multiplication of those letters, those are indices of a letter in question. In this case, we've got n. So count the indices of n index 1, n index 2, n index 3, n index 4, n index 5, and n index 6. So the answer is 6n index 6. That is 6n index 6, and that is a simplified number. When you find such a kind of expression, please do simplify in that category or that style. Then that's how we simplify different expressions of mathematics. Then we shall go to number 2. We shall go to number 2 for today. Number 2 reads, subtract 2m plus 6 from 6m plus 9. Says, do subtract 2m plus 6 from 6m plus 9. Wherever 1 is given that number, 1 must start with putting these 2 in brackets. The brackets must be respected, without which you will be wrong. What is then the importance of those brackets? The importance of the brackets is to make each of the 2 a single party. To make each of the 2 a single party. It's like telling you subtract 3 from 10. You hear 3 and 10. There are 2 things, one separate from the other. So subtract 3 from 10. So the comprehension or the understanding of it is, that is 10 minus 3. So there are 2 things, 10 minus 3. Whereas these ones have got unlike terms, that's 2m and 6. How can you make them one or singles? By putting them in brackets. So I've got subtraction of this one from this one. Like you heard me say, subtract 3 from 10. So 3 is one thing, and another 10 is a different entity. So the brackets make them single entities. So there are only 2 things, one separate from the other. Please remember, put them in brackets. If brackets are already put by the examiner, well and good, and many examiners will not then put the brackets for you. So by putting those brackets, it will show that you actually, or you were actually taught by your teacher at school, and then actually learned from the teacher. And now, get the meaning. Like I say, subtract 3 from 10 means 10 minus 3. Subtract 2m plus 6 from 6m plus 9 means 6m plus 9, please in brackets, minus that one, or the first one, 2m plus 6. That's what it means. So you have to change the order. When you hear separate from, where from is where you write first. So that number that bears the word from is the one you write first in interpretation of that statement. So subtract 2m plus 6 from 6m plus 9 means 6m plus 9 in brackets minus 2m plus 6. And then you open the brackets. You open the brackets. Now that we don't have anything open in the brackets, here the brackets just go off, meaning for the first one, just write 6m plus 9. And here a negative is the opener. Remember what I mentioned before. When the negative does open the brackets, all the signs inside the brackets have to change. Without that knowledge, you'll be able to fail that number, meaning you won't be able to pass it. So, which kind of integer is 2m? It is a positive one. It will then turn to a negative when the brackets are gone. Then this is a positive 6 already. it turns to a negative when brackets are gone. So when brackets do disappear because of a negative opener, then you have to change them to their opposites. Opposite of negative 2m, sorry, positive 2m is negative 2m. Positive 6 is negative 6. Then the brackets are gone. So the new statement is 6m plus 9 minus 2m minus 6. And then collect like terms. That is 6m minus 2m plus 9 minus 6 as it is here. Then subtract. That is 6m minus 2m, which is the 4m, where 9 minus 6 is the 3. And the answer finally is 4m plus 3. That's how one subtracts the non-like terms from other non-like terms. Then we shall go to number 3. Example today that reads, what should be added to y plus 4 to get 3y plus 10? What should be added to y plus 4 to get 3y plus 10? If one wants to understand that number very well, one can set another question that's related to that without necessarily writing it to understand the related style. What should be added to 3 to get 10? What should be added to 3 to get 10? Or John says it's the 7. So, what should be added to 3 to get 10 is the same as subtract 3 from 10. What should be added to 3 to get 10 is the same as subtract 3 from 10. So this number has got a different language from the other one, that's number 2, but they actually mean the same. So what should be added to y plus 4 to get 3y plus 10 is the same as subtract y plus 4 from 3y plus 10. So the way I've done number 2 is the way we do number 3. Like I said, number 2, first make these two single entities by putting them in brackets. Don't forget the brackets. After putting them in brackets, then do change the order where the last one begins and the first one ends. So, like I said, what should be added to y plus 4 to get 3y plus 10 is the same as subtract y plus 4 from 3y plus 10. So 3y plus 10 in brackets must be written first, then minus the other first one, y plus 10. Like we did in number 2, you are going to open the brackets. Here I don't have any opener, so you write here without any brackets, so we just put it down here without any brackets, that's 3y plus 10. And this one being a negative opener, it changes the positive y and the positive 4 to a negative y and negative 4 when the brackets are gone. Thus, we have got 3y plus 10 minus y minus 4. And then you gather the like terms as 3y minus y plus 10 minus 4 in this statement before you actually simplify it finally and say 3y minus a single y remains 2y. Then 10 minus 4 is 6, thereby getting 2y plus 6 as the final answer for that question number. Remember, number 2 and 3 have got the same interpretation but different wording. Never should you fear to work out as teachers explained today. Then we can go to number 4, example today. Solve the following equations. Having learned how to simplify now, we are going to do the solution of different equations as we are going to understand today. Part A says, solve p plus 3 is equal to 9. P plus 3 is equal to 9. If one wants to get a solution in algebra, one does the opposite. The opposite of plus is a minus. So when the examiner says a plus, do a minus. In that way, you have a permanent remedy or solution to that kind of problem brought. So we say p plus 3 minus 3 is equal to 9 minus 3. We do the opposite, that is whereby to spoil a plus 3, bring a minus 3, then it will be a nothing. That's why we've got a p plus nothing, meaning the plus 3 has gone the other side, this value is the other side, after the equals, which is equal to 6, which is the difference between 9 and 3, and therefore p is equal to 6. In so doing, the value p will be a 6, meaning in the place of p, one can write a 6, and then the equation is correct. Remember, the equation was saying p plus 3 is equal to 9, which p is a 6 now, 6 plus 3, one gets a 9. So, in proving it in that way, you will know that your value p is actually a 6, which you will never change. Then go to part B of number 4 today. So, 6 plus y is equal to 14. This time around, the unknown is added, whereas in part A, the unknown was starting, here is the second. So that is 6 plus y is equal to 14. 6 being a positive, you spoil it with a negative of the same kind. So we say 6 minus 6 plus y is equal to 14 minus 6. What you do this side is what you do the other side. I said 6 minus 6 plus y is equal to 14 minus y. So that the value of 6 is now spoiled here, where 6 minus 6 is a 0, then plus y, which is equal to the difference between 14 and 6, which is an 8. So 0 plus 8 is equal to 0 plus y is equal to 8, where y this side is equal to 8. Now check whether you are correct by substituting the value of y in y, which value of y is 8. Now see whether where y is, let's somewhere substitute 8 and see whether the answer is actually 14. 6 plus 8, is it actually 14? Try to add and see. Indeed it is. So the value of y is actually 8. Then we shall go to part C of number 4, or example number 4 today, that says solve for E, given that E minus 3 is equal to 10. Solve for E, given that E minus 3 is equal to 10. Like I said before, when ones are made in the minus, you actually add, put a plus sign of addition to spoil the minus 3. So you say E minus 3 plus 3 is equal to 10 plus 3. E minus 3 plus 3 is equal to 10 plus 3. And now you order. Normally we start with the positives. The plus comes this side and the minus goes the other side to understand it better. That is E plus 3 minus 3. E plus 3 minus 3 is equal to 13, where 3 minus 3 is a 0. E plus 0 equals 13, where E is actually 13. Check whether 13, when somebody takes away 3 from 13, gets a 10. So 13 minus 3, is it a 10? Yes, then we are good. E value is actually 13. We go to part D of number 4 and work out. Where 4 minus m is equal to 12. So for m, where 4 minus m is equal to 12. Now we are spoiling the 4. Which kind of an integer is 4? It is a positive. To spoil a positive, bring a negative near it. So we are going to subtract 4 from either side. That is 4 minus m is equal to 12 minus 4, where 4 minus 4 is now a 0. The value of 4 is on the other side. And now we've got 0 minus 4 is equal to 8, which comes from the difference between 12 and 4. And now 0 minus 4 is negative m. I'm saying 0 minus m is a negative m, which is equivalent to 8. And now when you are solving these equations, ensure the unknown doesn't bear a negative. When you say solve for m, it's the same as solve for positive m. So m cannot remain a negative. And remember, teacher told you, by saying m, we actually mean 1m, but you're not allowed to write 1m. So when you say negative m, I'm meaning negative 1m. So we are leaving this m with a negative, which is a negative 1. So we divide both sides by negative 1. Negative 1 is actually here, but we're not allowed to write it here against m. So negative m divided by negative 1 is equal to 8 divided by negative 1, where m is equal to negative 8. Remember, a negative divided by a negative, a negative divided by a negative, a negative divided by a negative, one gets a positive, and a positive divided by a negative, one gets a negative. So the equivalent of the unknown can be negative, but not unknown. So don't stop at negative n equal 8. Please proceed on to division on the other side by negative 1. And why negative 1? I told you you're not allowed to write negative 1 against m, but it's actually there. So it's negative m divided by negative 1 is equal to 8 divided by negative 1. And therefore, I've got m, which is equivalent to negative 8. And then part B says, solve for x if x divided by 3 or out of 3 is equal to 6. X out of 3 is equal to 6. But remember, out of, as I said before, is actually division. So you must know which operation you must provide an opposite to. So the opposite of division is multiplication. Here you must first identify the parties involved. So this is the sign, the equal sign. So we say party, sign, party. Party, sign, party. So I've got two parties. So you must again know, being that this is a fraction, this must also be a fraction. So make 6 or write 6 as a fraction. So it is 6 out of 1. Any whole number that doesn't have a denominator is out of 1. So 6 is out of 1. So determine the LCM of the denominator 3 and 1. So LCM is ever for numbers down which are called denominators. So LCM of 3 and 1 is 3. That's why we say LCM is equal to 3. Remember, there are two parties, meaning you are multiplying either side, that is each party by 3. So we multiply both sides by 3, that is 3 times x out of 3. When times is near x, this x changes to that kind of x to avoid writing things that look alike, like this. Some will not know that you are actually meaning the times and this is x. So that's why we write times x out of 3 equals 3 times x. Sorry, 3 times 6. So we multiply both sides by, say, LCM, and then we divide. 3 divided by 3, 1. 3 divided by 3, 1. Thereby remaining 1 times x, and now x goes back, alphabetical x. The other is mathematical x. This is the alphabetical x, which must actually write. And 3 times 6 is 18, where x is of value 18. And now substitute and see whether your answer is correct. Learn to prove your answers. It's only mathematics as a subject that has got proof for every answer, so that when learned, you never fail in particular number. If x is 18, check whether when 18 is divided by 3, 1 gets 6. Indeed it is, then the value of x is actually calculated or computed today, and no one can then lie to you. You fail that number. We shall go to part F of number 4, which tells you to solve for x, given that x plus 4 divided by 3 is equal to 10. X plus 4 divided by 3 is equal to 10. Still first determine the number of parties you have. This is one fraction, which is a party, and this is an equal sign, which is a sign, is a party. Say here, party, sign, party. Party, sign, party. Still have two parties, and remember, like I said, 10 as a fraction is out of 1. So the LCM of 3 and 1 is actually 3 again. So LCM is equal to 3. We are going to give it to the two parties we actually found out here before we went to this other kind of step. So we multiply the party or both sides by 3. So 3 times x plus 4 out of 3 equals 3 times 10. And now cancel by 3 ones by 3 ones, thereby remaining with x plus 4. This side, please bring back our original x plus 4 equals 3 times 10, which is 30. And now you work out for the value of x. You say x plus 4 minus 4 equals 30 minus 4. X plus 0, which is the 0 there, equals 26, that difference. Therefore, x is equal to 26. Check whether your answer is correct by replacing or substituting x into 26 in the original equation. That's 26 plus 4. 26 plus 4 is 30. Now 30 divided by 3, you get a 10. And now, without any worry, you will know that the value of x is actually computed to be 26 and never one lie to you, you fail that number. And then part B of number 4 says, solve for g if 12 divided by y is equal to 3. Solve for y if 12 divided by y is equal to 3. And now, you still identify the parties involved. You say party, sign, party. There are two parties. And remember 3 is out of 1. Find the LCM of y and 1, which LCM is y. So you are going to multiply either party by y, thereby writing y times 12 out of y is equal to y times 3 or 3 times y. We say now, by y once, by y, we are dividing. Y divided by y once, and the y divided by y is 1. So this side, mainly with 12, which 12 is equal to 3y, which was written the other way around as 3y is equal to 12, and now you are going to divide the other side by 3. 3y divided by 3 equals 12 divided by 3, so that you get by 3 ones by 3y, and here by 3 ones, 12 divided by 3 you get 4, so that y is equal to 4. Check whether you are correct by substituting the value of y, which is the 4, where y is. So you say 12 divided by 4 is actually 3. Therefore, the value of y is the real 4 you got. Before we go to part H, which tells us to solve for p, given that 4 into 3p minus 2 minus 5 into p minus 3 is equal to 28. So for p, if 4 into 3p minus 2 minus 5 into p minus 3 equals 28. Now, as I said before, we start by opening the brackets, and remember, a positive opener does not change any sign inside the brackets, whereas the negative opener does change every sign inside the brackets. Please ensure that element is actually maintained here. Remember, open the brackets by multiplying the quadratic brackets by the outside limit. This times the 4. 4 times 3p, you get 12p. Then 4 times negative 2, you get negative 8. Then negative 5 times p is negative 5p. And negative 5 times negative 3, you get positive 15, which is equal to 28. So thereby getting a new equation as 12p minus 8 minus 5p plus 15 equals 28. Then gather the p's together. That's what is called collection of like terms, and the non-p's together. That is 12p minus 5p plus 15 minus 8. We normally begin with those with pluses. That's why I started with plus 15 before the negative 8 came. So I say 12p minus 5p plus 15 minus 8, which is equal to 28. And now 12 minus 5, both are p's, that's 7p. And 15 minus 8, you get 7. The new equation simplified is 7p plus 7 is equal to 28. And then do positive 8 by, positive 7 by subtraction of 7 from either side. You say 7p plus 7 minus 7 is equal to 28 minus 7, thereby rendering this to be a 0. That is 7p plus 0 is equal to 21, where 7p is equal to 21. And now we're going to divide either side by 7. That's 7p divided by 7 is equal to 21 divided by 7. By 7 once by 7 we get p each side. 7 divided by 7 is 1, and 21 by 7 gets 3. And thereby getting p is equal to 7. Prove your answer before you continue. Where p is a 3, so 3p make 3 threes. 3 times 3. So 3 times 3 you get 9. 9 minus 2, that's a 7. That is a 7. 7 times 4, you get 28. So this, we have got 28. Remember, I've got 28 here. We are trying to prove, and remember, should be right here. We are trying to prove. And now, p value 3. 3 minus 3, you get 0. 0 times 5, you get a 0. So this side I've got 0. We have 28 minus that 0, you get 28, meaning 1 will not lie to you that you actually failed that number. That is the outcome. So a proof must be actually looked at keenly so that you don't fail that number. no one will tell you that for that number if you have proved your answer. Then part I, number 4, that takes us to solve. Solve for k. If 3 index, this is index, be careful, this is a power of index 1 exponent. So 3 index k plus 1 is equal to 27. 3 index k plus 1 is equal to 27. Now, in this regard, don't take it as 3k, this is a power. So, if this is a power of 3, so mass 27 turned to a power of 3. You are going to use the idea of factorization. Factorization you learned in the first term to work out this number, meaning express 27 in powers of 3 or in indices of 3, meaning 27 must be divided by 3 throughout in the side work. You say 27 divided by 3, you get a 9, 9 divided by 3, you get a 3, 3 divided by 3, you get 1. So count the powers of 3 or the indices of 3 in 27. That is the first index of 3, the second, and the third. Meaning 3 index 1, 3 index 2, 3 index 3 has been given rise to by that 27. So 27 is equal to the third power of 3, or 3 cubed, or 3 index 3, according to your wish. So replace the 27 with the index of 3, that is 3 index k plus 1 equals 3 index 3. So you compare with the same indices. So both are indices of 3, then you can now compare. Equals shows the comparison. So we say, since 3 is equal to 3, then k plus 1 is equal to 3. Since the downwards are equal, then the upwards as well. Since the bases are equal, so are the indices. So since 3 is equal to 3, and then k plus 1 is equal to 3. That's a new equation which you are going to solve, and then work out for k. So we say, since the examiner has got a plus 1, we shall introduce a minus 1 on the other side. That is k plus 1 minus 1 is equal to 3 minus 1. That is a 0, that's k plus 0 is equal to 2, where k value is a 2. In that regard, you will be able to find out how the value of k is in that equation. Remember, this is not 3k, it is an index of 3. So be careful with such a scenario, and you will be successful. Algebra is very enjoyable, and will make you enjoy mathematics if you actually follow what teacher teaches, and you will be successful in mathematics. It constitutes the greatest part of mathematics. Almost every number in mathematics is at the break. And therefore, if someone is conversant with algebra, that very person will be a successful man in mathematics. I am teacher Katimbo Richard, that has helped you know what you need to know, that is evident in algebra. In the next session, we shall look at how one forms the algebraic equations, because today they were formed for you to just mere solve. So wait for it, and therefore you will be successful further. I said, I'm teacher Katimbo Richard. If you want to reach me, call me on 0776 251655. I said on 0776 251655. Remember, COVID-19 is real. Please wear a mask as soon as think about going to the public. Otherwise, stay safe.